Yeah, hi everyone. So now here we will discuss DMVPN, Dynamic Multi-Point Virtual Private Network. In this DMVPN, it's a VPN kind means virtually will create tunnels. So for that, our safe and securely our LAN user can communicate to each other. These are the main LAN users. They can communicate at a different location, different branches. Here we have a branch 1, branch 2, and branch 3. So safe and securely they can communicate overlay through not for the internet, through internet. So internet is actually not safe and secure a way to reach. So it's kind of only will here with the help of NAT service will create a reachability. What it will do, network address translation. NAT stands for it will be convert public IP to private IP addresses. NAT will be convert public to private and private to public. So it's kind of underlay reachability. It's kind underlay reachability, but after underlay reachability done, will create overlay. So in this overlay, will advertise our prefixes. Which prefixes? Our LAN prefixes will advertise. It overlay in this tunnel. They can communicate safe and securely. So for that, we have a DMVPN phase 1 and phase 2 and phase 3. So in this phase 1, only point to point connectivity will be happen. Point to point. So it means hub to spoke, and hub to spoke. Like this, we can communicate. If you want to reach from spoke to spoke, yes, we can able to reach, but the communication is like again from it will be moved to the hub location, then hub will transfer to spoke location. They will via they can communicate with hub. That is not possible at spoke to spoke. Only here it will be possible hub to spoke only. We can communicate hub to spoke. So here we have a two types of phase 1 configuration. One is static and another one is dynamic NHRP configuration. So earlier we did static configuration. Now we'll try to do dynamic configuration here. So I do have default configuration. I'll provide you in description. So just go through the description and there you can find out our entire configuration. So here in this notepad, we have a dynamic phase 1. So DMVPN, dynamic multi-point VPN, phase 1 dynamic configuration. We have dynamic NHRP configuration. So for that, this is a router 1 and it's a router 2 configuration and it's router 3. It means it's a spoke 3 configuration, branch 3, and this is the ISP configuration. In ISP, we configured only interface level only. It's a basic configuration we did. Apart from that, we haven't advertised any routes. Just we make a reachability from this IP address to next hop IP address of this one. So just we make a reachability. So with that is the reason we are advertise from here a default IP address. Based on that, it will be advertised. So if you want more about it, just go through previous videos, everything we discussed. So now we'll configure. So before that, what we'll do, we'll wipe entire devices. Wipe means I am restarting. It means the entire devices will be configuration I am removing. If anything earlier I did, the entire configuration, it will be wiped. Just selected devices, it will be wiped. So done. Now wipe is done. You can verify from here. So once you wipe, then restart it. If you need this topology, just comment and send me the message. I'll provide you. If you want, just comment in below section. So I'll provide you the entire images also. It's EVNG. If you need more about EVNG videos, just comment it. I'll upload those videos. So not started properly. I'll start once again. So here it's a ISP router. And so we'll start to do configuration. Just copy and paste. I'll provide you the entire configuration. Copy from up to here. And it's just spoke. Before that, we'll configure a hub location. It's hub location configuration. Just select the hub location router, enable, and it's done. You can check here. The name is changed. Now move to spoke location. It's a branch one, spoke one. It's branch one router. And now move to batch one configuration part. Just enable, then right click it. Just right click it on the automatically it will be take the configuration and that. Next spoke to, it's branch two. It's a branch two router. Select from here and enable. Just right click. So by default, no configuration is there. If you want to check, I'll show you in router 3. Before that, just we copy here. Before the paste, I'll show you the configuration of spoke 3. So you can verify from here. Show IP route. Yeah, no routing protocols we have. And show IP interface brief. You can verify with any assigned IP addresses, even though we haven't configured any host name. So just copy from here the configuration and right click it. So done entire configuration. Still we haven't configured ISP router. So only basic configuration we did in ISP router, only interface configuration we did here. Can verify from here and go to ISP router and just enable and right click it and now done. So now we can verify the entire configuration before the will save with that. So you just use the save configuration for right and show running configuration. You can verify with entire running configuration through this command. So you can check here. Yeah, it's tunnel interface what we did, and we created one tunnel 100 interface. In that we assigned the IP address, and here we assigned like NHRP network ID. It's one. It's kind of in OSPF will use process ID, right? Have you remember? And the process ID based on that, what it will be do? If multiple customers are there, so every pro will give a different process IDs. For customer one part will give the one process ID and customer different customer parts different process ID will assign. So the same likewise here we have a NHRP, next hope resolution protocol For that, we'll assign the network ID. It's kind of only one location. So make sure it will be not matched to other routers, spoke routers or hub routers. So if you have multiple branches, so take multiple network IDs. So for that, and tunnel source, I have taken here source interface, that is fast Ethernet 0 by 0. And earlier in GRE, we take the IP address, but here we have taken the interface name, whichever the port name we have taken here. And that is what here we have to see. Earlier, the destination we configured in GRE, but here we haven't configured the destination. Here, destination part, so multi-point we configured. So multi-point means it will be convert. The point will be we configure like the tunnel in between branch 1 to hub and tunnel in between branch 2 to hub and tunnel in between branch 3 to hub. So likewise we configure. That is what? That is multi-point to spoke location we configure. That is we call it as. So now move forward here and this is all about the interfaces, and we define a IP routes for. This is a next hop IP addresses. Here we configure not a physical interfaces. We configure tunnel interface. It's a tunnel means it's a virtual interface. That is our final achieve goal. So here default route we configure towards ISP. So in real time also same like we will configure in real time also. That is what we discussed in NAT. So if you want to check more configuration of interface tunnel, show running configuration interface tunnel 100 we have taken. So this is what, and show IP HSRP. Sorry, NHRP, next hop resolution protocol. This is what. So here our destination is 100.1.1.2 and via the next hop IP address is 100.1.1.1 and tunnel is we created 100 and it will be expired, but the next hop IP address is default route. So in next hop IP address is here physical IP address. If you want to take a reachability for 100.1.1.2, yes, we have a reachability and 100 dot pin 100.1.1.3. It's a branch to tunnel interface. Yeah, we reachable. We can able to reachable tunnel interface 100.1.1.4. From we can check the branch 4 also. In branch 1, we can able to reach our branches. Just first we'll ping hub location 100.1.1.1. It's a hub location. Yes, we can able to reach, and it's branch to same, and it's branch to router. It's branch to spoke to IP address we can able to reach, and spoke 3 is 100.1.1.4. Yes, we can able to reach. But try to ping now LAN IP addresses 192.168.20.10 we haven't assigned PCs, but we have assigned the gateways. Now we try to ping the gateway. Try to ping the gateway of branch 1. That is our gateway. Yes, we can able to reach, and 30 dot it's branch 2 gateway is. So we'll trace out it. So what is the reason behind it? So basically we discussed, as we discussed, in this only we have a hub to spoke location, not spoke to spoke. So if you try to ping from hub location, yes, we can able to reach this interface. If you are trying to reach from here to here, no, not reachable. So before, so if you want to know about it, so till end watch this video. I'll show you the configuration. Before that, we'll assign the interfaces of IP addresses of LAN interfaces. So user interfaces will assign, host IP addresses will assign. Then we'll configure it. We'll check the issues are further. So how will assign IP just 192.168.10.10/24 and 192.168.10.1 is our gateway. And we'll assign laptop IP address is 20. 192.168.20.10.20 will assign. And here you can IP 192.168.10.20 and /24 and just close it. Now we'll assign the IP address of branch 1, that is spoke 1, and IP 192.168.10. So here we'll take 20.10 and /24 and gateway is 192.168.20.1 and try to ping now from spoke location branch 1 2 and hub location of users and ping 192.168.10.10. So we can able to ping, right? Good. Now trace it. Just trace 192.168.10.10. So first it reaches to our gateway, branch gateway of router of this interface. Fast Ethernet 0/0, that is what here. And it's moved to tunnel. It established one tunnel. Through tunnel, it will pass the information. You can verify here. In branch 1, we have another interfaces, but here you cannot see the next hop IP addresses of these interfaces. Cannot see because that is what we did here, VPN. That is what we did here, VPN. Great. Everything is working fine. But if you try to ping from tracer, try to ping from spoke to spoke. We haven't assigned the IP address. Just will assign the IP address of this PC also. Now we'll try to troubleshoot it. 192.168.10 dot. It's a 30.10 and /24 subnet mask and it's a gateway 192.168.30.1. It's a gateway. Now try to ping first hub location, then we'll try to ping spoke location. That is branch 2. It's PC13 is a branch 2 PC and ping hub location first 192.168.10.10. The reachability is perfect. It's pinging perfect. And try to ping this PC and branch 2 PC. Ping 192.168.20.10. So reachability is not there. So what we will have to do here, that is what. So here we don't have branch to branch connectivity, spoke to spoke connectivity. But we have a hub to spoke connectivity. Before that, try to ping the tunnel interface. The tunnel interface is here 100.1.1.2. Ping 100.1.1.2. So we haven't reachability again. So make sure you should have to reachable. Then only you can able to ping. So for that, what we will do, we'll check in this routing tables. So which our goal in this routing table will verify our destination is available or not. Show IP route. So here we don't have the prefix 192.168.30.0. If you have that prefix here, so then only you can able to ping. For that, we have to configure dynamically. We can advertise it dynamically means you can use RIP protocol, OSPF, EAGRP. But now we'll configure later on that. And in this series, I'll configure dynamic routing protocols also. But now I am configuring, I am advertising statically. I'll advertise that prefix. Config terminal IP route. It's a static configuration. Statically, I am advertising the prefix 192.168 dot. So before that, you can be able to check your reachability is ping with tunnel. Is tunnel is pingable or not? Which tunnel? On that spoke 3 tunnel is 100 dot, spoke 2 tunnel. Sorry, spoke 2 tunnel is 100.1.1.3. Yes, we can able to reach. So that is our next hop IP address. So configure, no, config IP route 192.168.30.0 and subnet mask 255.255.255.0 and next hop IP address is 100.1.1.3. Yes, we can able to reach. And same thing we'll do in this spoke 2 also. Spoke to will configure same thing. So once way communication is not happen, so we need a two-way communication. So that is the reason if you want to check the show IP route, we don't have the prefix of 192.168.20.0 prefix we don't have, so we have to advertise config t and IP route. In this we are statically we are advertising. Even though if you want to advertise dynamically, we have the option. So basically, GRE protocol, not GRE, generic routing encapsulation. It's a plain text, but on that protocol, you cannot advertise dynamic routing protocol. But in DMVPN, it is possible. So next hop IP address is 100.1.1.2. Done. Now you can check. Now you can check it. Go through the virtual PCs and VPC 13. VPC 13 and I have selected 13 and ping 192.168. Earlier we ping, right? Here I'll take a reference. Just ping 20.10. Yes, the reachability is there. Now try to trace it. Trace 192.168 20.10. So first it reaches to gateway, that is the spoke 3, spoke 2 gateway and 192.168.30.1 and it reaches to next hop IP address, that is hub location. It's a hub location. So tunnel is established in between spoke to hub. After then it will be moved to this location. So that is what hub to spoke location. Here we don't have opportunity, like we cannot configure it like spoke to spoke. So for that we have a phase 2 and phase 3. If you want this phase 2 phase 3 configurations, so just in below section comment it and I'll provide the videos. Thank you for watching. And before that, I'll show you some troubleshooting commands in DMVPN. So just enable and show interface tunnel 100. You can verify it, which configuration we did with this command. So our tunnel source and our tunnel destination is unknown. Don't, it means it's multi GREV enabled. That is the reason here showing unknown, but we have a reachability entire. It's a hub location. So that is the reason it is showing. But if you can able to check the same command in this, that is your assignment at spoke 1, spoke 2, spoke 3. So you will verify, we can find out the different thing here. What you will find out, just comment it. And move forward, show IP HSR. No, N. So NHRP So this is the IP address, our tunnel, and this is the next hop IP address of tunnel, and it's through this we can reach. This is our physical interface. This is a virtual interfaces. So IP interface brief, we can verify tunnel is up or down. Yes, it is up. So this is all about troubleshooting command. Thank you for watching and subscribe, comment it and like it. Thank you so much.